Imagine a star, not just any star, but one that dwarfs our own sun. Picture it burning with the intensity of 1,000,000 suns. Its surface a maelstrom of scorching plasma and stellar winds raging at millions of kilometers per hour. Now imagine falling into it. This is no ordinary star, this is a Wolf-Rayet star, a celestial leviathan on the brink of a spectacular demise. Our universe is a tapestry woven with threads of creation and destruction, birth and death. And you know, few objects embody this cosmic dance as dramatically as Wolf-Rayet stars. These are not the gentle, life-giving stars like our sun. They are cosmic rebels, living fast and dying young, leaving behind a trail of stellar chaos and the building blocks of future generations of stars. But what if, by some cosmic quirk, you found yourself on a collision course with one of these stellar titans? What would it be like to approach this inferno, to feel its heat scorching your very essence, to witness the raw power of a star ripping itself apart? Brace yourself, for we are about to embark on a journey to the heart of a Wolf-Rayet star, a journey that will illuminate the awe-inspiring power of the cosmos and the delicate balance between creation and destruction. Before we embark on our perilous journey, let's understand what sets Wolf-Rayet stars apart from their more sedate stellar brethren. First spotted in 1867 by French astronomers Charles Wolf and Georges Rayet, these stars are giants, easily 20 times more massive than our sun. But their size is only the beginning of the story. What truly distinguishes Wolf-Rayet stars is their extraordinary luminosity and temperature. These celestial behemoths shine with the brilliance of 1,000,000 suns, their surfaces heated to a scorching 50,000 degrees Celsius or more. To put that into perspective, our sun, a mere dwarf in comparison, simmers at a relatively cool 5,500 degrees Celsius. But the true hallmark of a Wolf-Rayet star lies in its fury. These stars are locked in a perpetual state of self-destruction, their outer layers blasted away by powerful stellar winds traveling at millions of kilometers per hour. Imagine a hurricane, not of air and water but of superheated plasma, and you start to grasp the sheer violence unleashed by these stellar titans. These extreme conditions arise from the star's internal struggle. Having exhausted the hydrogen fuel in their cores, Wolf-Rayet stars resort to fusing heavier elements, a desperate bid to stave off their inevitable collapse. This frantic nuclear fusion generates unimaginable amounts of energy, fueling the star's intense luminosity and driving its furious stellar winds. Now, let's embark on our hypothetical journey toward a Wolf-Rayet star. As you approach this celestial inferno, the first thing that strikes you is its blinding light. Even from a vast distance, the star shines with an intensity that dwarfs all other stars in the sky. As you draw closer, the heat becomes unbearable. Your spaceship, designed to withstand the rigors of deep space travel, begins to buckle and groan under the onslaught of radiation. Instruments malfunction, blinded by the star's intense light, and communication with Earth becomes a faint whisper, lost in the roar of the stellar wind. Speaking of the stellar wind, this is no gentle breeze. Imagine a stream of superheated plasma, traveling at millions of kilometers per hour, slamming into your ship. It's like being sandblasted by particles traveling at a significant fraction of the speed of light. Even the most resilient materials would crumble under this cosmic barrage. But the true danger lies not in the heat or the wind, but in the radiation. Wolf-Rayet stars emit intense X-rays and gamma rays, invisible to the human eye but deadly to all forms of life. These high-energy photons would penetrate your ship, scrambling your DNA and disrupting the delicate biochemical processes that sustain life. Assuming your ship could somehow withstand the onslaught of heat, wind and radiation, you would eventually reach the star's outer atmosphere. But instead of a solid surface, you would encounter a tumultuous sea of superheated plasma. Here, temperatures soar to millions of degrees, hot enough to strip atoms of their electrons, creating a chaotic soup of ionized particles. But the real killer, quite literally, is the star's immense gravity. As you fall deeper into the star, you experience the strange sensation of spaghettification. The gravitational pull on your feet becomes significantly stronger than on your head, stretching your body like a cosmic noodle. As you descend further, the heat and pressure intensify. Your atoms, once neatly arranged, are ripped apart, their constituent protons, neutrons, and electrons scattered into the stellar maelstrom. You cease to exist as a cohesive being, your very essence dissolving into the star's fiery embrace. There's a strange beauty in this cosmic dance of destruction. In the heart of a Wolf-Rayet star, where temperatures and pressures reach unimaginable extremes, the very fabric of matter is tested. Atoms are ripped apart, their constituent particles forced to interact in ways that defy our everyday experience. If falling into a Wolf-Rayet star during its normal life cycle wasn't dramatic enough, imagine plunging towards one as it enters its death throes. These stellar titans don't go out with a whimper. They explode with the fury of a billion suns, becoming supernovae, some of the most luminous and energetic events in the universe. As the star's core collapses under its own immense gravity, it unleashes a shockwave that rips through its outer layers, blasting them into space at nearly the speed of light. This explosion outshines entire galaxies, releasing as much energy in a few seconds as our sun will emit over its entire 10 billion-year lifespan. If the star is massive enough, its core might collapse even further, crushing itself into an infinitely dense point known as a black hole. These gravitational abysses are so dense that not even light can escape their grasp. Falling into a black hole would be the ultimate cosmic roller coaster ride, a one-way trip to a singularity where the laws of physics as we know them break down. While the thought of being consumed by a Wolf-Rayet star might seem like a terrifying end, there's a silver lining to this cosmic tale of destruction. In their death throes, these stellar giants seed the cosmos with the building blocks of life. Remember those powerful stellar winds we talked about? They're not just destructive forces, they're also cosmic gardeners. As they blast across the interstellar medium, they carry with them the heavy elements forged in the star's core: carbon, oxygen, nitrogen, iron, the very elements that make up our planet and our bodies. These elements, scattered far and wide by the star's supernova explosion, eventually coalesce to form new stars, planets, and even life itself. In a very real sense, we are all made of star stuff, the remnants of long-dead stars that met their end in spectacular fashion. So the next time you gaze upon a starry night sky, remember the Wolf-Rayet stars, those cosmic titans burning bright and dying young. Their story is a reminder that the universe is a place of constant change, where destruction and creation are forever intertwined. What if those scattered elements from a Wolf-Rayet star's demise eventually coalesced into a planet teeming with life? What if billions of years from now, beings on that planet looked up at the night sky and wondered about the origins of the universe, just as we do today? The cosmos is full of possibilities, and the legacy of Wolf-Rayet stars reminds us that even in the face of unimaginable destruction, the spark of creation always finds a way.